So today we will deep dive into API security, what you can do, and what are the best practices, what to be aware of, and how Traefik can help you along this journey. And we strongly believe that security should be handled at the gateway as a critical centerpiece of the infrastructure, and also the attacks that you are facing and the emerging threats these days puts in a position that it's not about an if an attack will happen or a data exploit or something like that, but a when, because it will happen at some point. So be prepared and fortify your API security. So before we jump into the topic, let's say a little about Traefik and Traefik Labs as a company. We are well known in the API world around our API gateway, API management, and the application proxy offerings. We are top 15 downloaded Docker image, and we have a huge open source community, and we are very welcome for every contribution that is possible. You are free to improve our product and shape our roadmap. And these days we are recognized by even big advisory firms, and we are leading the open source insights in API gateway category in the last 6 consecutive years. What we provide, what our product portfolio contains, lets you expose, secure, and manage APIs. And if I say that virtually on every platform on the planet, I might not be too far from the truth, because our products, our offerings can be run on any kind of Kubernetes distribution, any kind of cloud providers, and if you are not even in Kubernetes like Swarm or HashiCorp Nomad, we support them as well. Our product portfolio contains the application proxy that you probably already familiar with, and this is a very feature-packed reverse proxy offering that you can even get the production support for. But we have 2 paid products, the API Gateway, which these days also extended to the AI LLM space, acting as an AI gateway. And on top of that, we also have an API management offering now from the last KubeCon with an API mocking solution as well. So how these things operate is, I think, the secret sauce to all this, because all our products can be configured through GitOps with declarative configuration. And as you start your journey with the application proxy that is also capable of storing every configuration as code, and with a simple Helm upgrade, you can move up to the API Gateway solution as your needs evolve. We can grow with you if you want more security, more enterprise level integrations, and so on. There is a way to grow. And if this is not enough, you want even more API governance, API observability, or even a developer portal, you can do also a simple Helm upgrade with a new license key, and you get API management. And all of these are in an additive way, not addictive, but additive. This is meaning that the previous layers are contained in the higher levels. So what you get as an application proxy, all the configurations, everything can stay the same when you upgrade to API Gateway. It understands the previous configurations, but unlocks, adds more features to the picture, more configuration options, more knobs that you can tune. And as you move to API management, it embeds the gateway and just adds more features on top of that, more CRTs and things like that. So enough of the journey and the company side. Let's look into our security topic today. What we will show and what we will guide you through today is can be expressed as a multi-layer security approach, meaning that whatever we show can live on its own, but probably doesn't make sense to just have one piece, but these things can work together, and on top of each other, you will fortify your gateway, your central infrastructure piece in the critical paths of all your requests, and leverage more and more protection. You start, of course, you start somewhere, then become aware these things exist, or these features, how you can use them and leverage them to your protection and to your customer data protection, and to comply with different regulatory requirements and so on. We think there are three main categories that we will guide you through: encryption, access control, and threat defense. And we will see different topics inside them, but of course this list is not exhaustive. You can do a lot of things, but these are key examples, key must-haves that we believe in. And we wouldn't be Traefik if we don't offer something as other bonus content, so you can expect even something more at the end. So let's dive in. First of all, we will talk about traffic encryption, which can sound as something that too basic to discuss. Everybody uses certificates to encrypt their traffic. HTTPS these days should be considered normal. Even the browsers encourage and block the plain access sometimes. But with our friends at Treble, we are in partnership with this API observability company. They have access to lots of data, and they process billions of requests, and they provided an analysis of last year that they processed the billions of requests and what they could see from what patterns emerge. And honestly, when I checked the report, you can have access to it freely. One thing really stood out to me, that 55% of the requests didn't use any kind of encryption. So it was plain HTTP request. And this means that more than half of the requests, which is astounding. And even if the topic feels a little embarrassing to talk about, that we should prioritize first and foremost, at first, to encrypt the traffic leaving or reaching the gateway. So this is the first topic, and let's see how we can help you with that. Level 1 basically is when you manage your certificates manually. This is maybe not something bad, or maybe this is something that you must live with. For example, the company purchases your certificates from trusted certificate authorities for a couple of thousands, or like big banks usually do this. And then the certificate is with an extended period of time of how long it's a valid certificate, and you don't need to automate the rotation of the certificate, and you just do this, like, let's say, yearly. In this case, you bring your own certificate, and this is fine. You just apply it to the gateway, and now your traffic is secured. But if you want to take away the manual approach, maybe you don't want to forget this, or you can use free certificates offered by, for example, Let's Encrypt, which is, I think, the most well-known certificate authority these days that provides free certificates. You can leverage the ACME protocol, which is to manage automatically the life cycle of certificates. And Traefik offers both in proxy, also in gateway and in management solutions, an automated way of managing certificates. Of course, because this is Let's Encrypt is based on the ACME protocol, that means you can use any other ACME compatible solution. And This opens up the level 3 when you don't rely on a third party, but you manage your own private key infrastructure. And for example, with our gateway, you can have an integration with the HashiCorp Vault that can not just store secrets, but also certificates, and also supports the ACME protocol, can do the revocation, renewal of the certificates. So this way, you can secure your traffic, and you don't need to be afraid of man-in-the-middle attacks or somebody, a malicious attacker or actor, modifying your requests or response data. And I know that sometimes the APIs start as internal APIs, and then somebody decides to expose them, and then they don't do the work to secure them. So be prepared and even treat internal APIs with, for example, the domain name validation. You can issue certificates for subdomains that are not even exposed to the internet. So even there is no excuse for internal APIs to be left unsecured without TLS or SSL encryption. So this is the first point. Let's move on to the next. I have a $1 bill with me, courtesy of one of my teammates, and it says on the back that in God we trust. This is something that I can tell that is, let's say, not sufficient or not a good strategy only if you trust everybody in IT security to be a good actor, because they will be not a good actor all the time. And from the analysis provided by Treble, we can see that 52% of the requests had no form of authentication in 2024. That means last year, more than half of the APIs were unauthenticated. And I don't believe that everybody in this webinar is running only public-facing APIs, like Google offers their search without authentication, or websites or e-commerce sites needs to offer some product listing pages without authentication. But most of the valuable traffic and everything that is related to money, of course, should be authenticated. And even the internal infrastructure is not without threats, because I have just the latest insights that Beyond Trust, even the name of the organization was Beyond Trust, they faced an API key breach that in the end of last year, it caused a lot of trouble to them. You can look it up on the internet, what troubles it caused, what was the outcome of it, and how could they prevent it. But what is most important from this, that when you start even building internal APIs, you should put some form of authentication, even between microservices, because as your company, as your organization evolves, you will want to open up more and more internal APIs to external parties, because you don't want to reinvent the wheel. You don't want to re-implement those microservices again as public-facing APIs. But somebody at some point, maybe after you leave the company and so on, will do it. And if you don't have the enterprise level authentication in place, then you are not protected. So basically, you should authenticate everything, and unauthenticated API calls should be the exception, a deliberate choice that you don't put any kind of authentication in front of them. Of course, it depends on what level of security you will implement, or what can you afford, and so on. For example, basic authentication might not need an identity provider, but we think and we believe that identity provider, a good identity provider, is the basis, the foundation of a proper and good API governance. You should start from that, managing your users at the central location, and then if you have this piece somewhere, either in the cloud or managed by yourself, then you can build on top of that and use JWT, JOT, or OIDC or OAuth2 as authentication and authorization layer. And we provide these features that I think is a war crime not to include within your infrastructure. So after requiring valid credentials, that does not mean that even when, for example, based on this recent data breach, it does not mean that the party that holds this key, for example, can be trusted. So the next one, the next layer you can apply is that you need some level of protection on these APIs by abuse and overuse protection. I mean, that, for example, web crawlers or others like different nation states or different hacker groups might want to take down your infrastructure, or basically you offer some services that you are in front of the, you are on the trenches of a war, and they will come and attack you by no chance. It's not about the if, it's about the when. And from the analysis of Trevor, we can see that 85% of all APIs had no kinds of rate limits in the last year, which is kind of amazing. To me, as a product manager of an API gateway and management solution, rate limits are kind of basic. Everybody should use that. But it turns out that the majority is not using that. So how can we help with this? First of all, you can limit the traffic incoming by IP address. That means, for example, if you run some internal APIs and you are just using API keys, you can limit the source to the internal infrastructure, and if the key is exposed externally, then those IP addresses cannot pass even they have valid credential. But of course, with this breach of Beyond Trust, they, for example, had a breach in a way that the attacker could reach their internal infrastructure even. So maybe IPLO list, the middleware we offer, is not a fully not providing full protection against these kinds of attacks. But this is one measurement you can still apply. It's good, but it's not good enough in itself. So this is why you need to apply different levels of protection. And here, even the second level can be applied together with, for example, the IP address or range limit. That, for example, a client, mostly web crawlers these days, or even attackers with distributed denial of service attacks, they issue a lot of requests towards your APIs and try to overwhelm the gateway with requests. And one protection mechanism you can apply is to limit the requests that are allowed in parallel from one client to your gateway. Of course, you could say that this does not protect if the client has multiple IP addresses, but still, as a protection mechanism, it provides you one level up from doing nothing. So if you want to do even more than that, then comes the request flow and overall amount control with a, let's say, a real rate limit. This is usually something we just refer to as rate limit, because this is usually in the company. But otherwise, this is something that you should implement even in the open source version of Traefik. You have the rate limit middleware that you can apply and limit how much requests in overtime can come from clients to your gateway. And when this window of requests is exhausted, like within an hour or within a minute, they exhaust the available amount of requests, then they will get a rate limited response until the window slides towards, or the tokens in the token bucket algorithm renewed. I don't want to exhaust you with too much technical details on this, but This is something that you can even implement if you are using the free version. But if you are running API gateway or API management, you have access to something we call distributed rate limit and distributed quota. That means if you have a Redis installation, highly available Redis these days is not something that you cannot achieve within a couple of minutes or even hours. So that means Redis is usually living somewhere in the infrastructure. If not, it's not a big deal to set it up. Then you can share the rate limit counters between the different API gateway replicas, because probably you are not running just one API gateway replica, but multiple scaled out horizontally architecture. And this way, the rate limit you set, the counters will be distributed among the replicas. So all of the replicas see the same counter. So there is no excess rate limit that, for example, an attacker could use, that they are targeting another replica that is still has some rate limit left. No, every replica sees the same counters. So this is what I mean, that you can level up your security game, that there are many protections that are available, and even Traefik has a plugin catalog that you can look through. There are other solutions and other middlewares even built in, and this takes us to the fourth option, web application firewall. This is available in the open source version as a WASM plugin, but you can also use the API gateway and API management side. On the API gateway side, the built-in, the highly performant native integration of the core as a firewall. And we have a blog post about that on our website that you can check. It contains some measurements. You can 25 times more it can be 25 times more performant than the plugin based option. Of course, if something processing is in the critical way of the data path, the processing takes up some time. So this is why the gateway offers a native integration to be highly performant. And this firewall is not something we made up on ourselves, but this is the open source Corazza firewall, which has OWASP endorsement. And if you are familiar with the OWASP top 10 security list, for example, this is the organization behind it. So it's a well recognized organization, and they endorse using this solution. And this is something that even the firewall, the web application firewall, that is in the different regulatory requirements. For example, PCI DSS requires you to have a WAF. So you can fill this gap easily. And here, as the example, I'm just showing that you can turn on, for example, CQLI injection, CQLI injection protection with just 2 lines, or you can enable the whole core rule set, or you can fine tune it as you like. But this is a really powerful tool that can protect you from known attacks. You don't need to reinvent the wheel. Use the existing information gathered by the community and apply it to your defense. But a WAF in itself can be good, but if you move to the next one, you should also adopt a zero trust based approach or perspective to your APIs, because when you provide access to everything, you offer all the capabilities of this API, and maybe at some point the business will develop new endpoints to this API, and those will be automatically exposed. But this should be reversed, like with today's approach in computer security. For example, the IT security departments of companies require the usage of VPNs. Even when you are sitting in the office, you will connect to a VPN, and this way, the attackers next door, if they crack your Wi-Fi password, they have no access to the infrastructure. They just might have access to your printer, but not to the server infrastructure, because all available through a VPN. They trust no one, even sitting in the office. So this zero trust approach is also valid for APIs. You can limit with Traefik Hub the method and URL paths, what you provide access, and provide regex matching, and go wide on what you want, even with and or logical expressions. And you can define these rules once and then reuse it later, and it supports APIs and API versions, so it's very flexible. And why not use it when the framework is already there? You just need to get used to it, and maybe provide some internal policies that these things must be provided, must be configured from day one. And the sixth topic is that, okay, now you put many things in place, but still you will use, for example, API keys with third parties, like these days LLMs and AI are a big topic, and these services are accessible with OpenAI, with Gemini, and so on, with a single API key. And whoever has the API key can exhaust your tokens and the credits you have in your account, and drain the attached bank account easily. And this way, you don't want to provide the key even to trusted sources. You want to manage it centrally. And this is where we can also help. And altogether, the gateway pattern can help with this, that you store the secure credentials on a secure place that you control on the gateway, and you just provide the local credentials to your end users. You generate short-lived tokens that they can use, and that you can easily revoke. And this is why the Traefik Hub API gateway, when acting as an AI gateway, it can protect these upstream endpoints, these AI endpoints, and we effectively can turn any AI endpoint into a managed API. And then even you can publish them on your developer portal and provide internal documentation to it, who to contact, who to how to get access to it, and so on. So really, secrets and keys are usually a hot topic in security. You should pay attention to them. But moving on to the next one, the last one, of course, you will evolve. Your needs will evolve. Your business will evolve. And as all things, some things will be maintained and some things will get less attention. And Treble, in the recent report, they analyzed that 35% of endpoints were zombie endpoints in last year. This means that these API endpoints were kept accessible externally or internally, but become unmaintained. Maybe the development shifted, maybe it's running well and doesn't need any attention, and become, let's say, unpatched because of security advancements and CVEs upstream, in the upstream operating or programming language, for example, that microservice is built on. And these unmaintained APIs pose more and more threat to organizations these days. So with Traefik Hub, our latest addition, which was just released like last week or something, this protects you from these zombie and shadow APIs easily, meaning that you can turn on, as you can see on the example, you can turn on one flag, one boolean, switch it to true, and everything else what is undocumented will be blocked. Every request that does not conform to the OpenAPI specification that you attach to an API will be blocked easily, just like that. And basically, this means that when you have an OpenAPI specification, that is containing the schema, the methods, the paths, the schema of the JSON requests, and so on, which level of authentication and how do you configure authentication, all these things contained in the OpenAPI spec. And we check against that all the requests that are coming in, and we can block everything that is outside of it. Because if something is outside of it, that means that can be unknown API endpoint. And when you have an OpenAPI spec, that can assume that you know about these APIs and that you can show to auditors, that you can check programmatically because other programs can process it, can test it. And this is why we take this approach to block everything outside of the Open API spec. And this is basically making every CSO's dream come true, because with one single Boolean, you can make this happen. But you could ask, of course, this is great when you have an Open API spec, but what if I'm operating legacy software, maybe something running on a virtual machine, but still exposing APIs. The developer left the company 10 years ago. It's written in an unmaintained language even, and so on. What can I do? And this is where our partnership with Treble can come into the picture, because applying a single middleware on the gateway and connecting Treble observability into the gateway, every request that you will pass through the gateway will be logged. The access log will be available, which payload it contained, which headers it contained, and so on, which method, which path was accessed. And Treble has a feature, a capability to build up the OpenAPI spec from observed traffic. Of course, this can still leave out some niche use cases that these specific endpoints were never called in the past year or something. And if you apply the generated OpenAPI spec to this setting, then you might block something legitimate traffic, of course. But this is a very good starting point. You turn this on, build up the OpenAPI spec, and after, if you think 1 month of grace period or a week, or you define the period, is enough to build up a good enough OpenAPI spec. It's a good starting point. You apply it, and then you will proactively take action to even extend it to contain all the capabilities you want to approve and allow. So this is something we will also demo today, which is quite powerful. But as I mentioned, we also have a bonus topic for you. And that is something that is not directly connected to security, but can become a very useful tool in API security. And this is observability. And with, within Traefik, we believe that all the metrics and tracing and logs should be exported as open telemetry. And the new addition to Traefik is logs, because previously we already provided very good API level metrics, and the gateway was traceable with tracing header propagation to apply distributed tracing. So it was not a black box as some other gateways on the market. But now we unified the whole story around open telemetry, because we provide also logs as open telemetry format. And you can bring your best, you can bring your most well-known tools that you have in place, like Grafana, for example, or Datadog, or any other solution that can provide you open telemetry ingestion capability. And then if you connect your CI/CD pipeline, your GitOps workflow with the observability stack. And here is an illustration that, for example, Flux deployments are marked on as an annotation on this Grafana dashboard. You will know when something was changed, and you can correlate the incidents to any change. And with the power of Git, you can easily roll back to a previous working state, and then you will have time to deploy the faulty state to a separate environment. You can investigate, and you can actually mitigate the incident and resolve the incident and redeploy the fixed code. But the incident resolution can take up time. And here you will have incident mitigation instantly through Git. So this is, I think, a very key piece of or important point of security, because here, without this, you will fly blind. you will not see if request rates spike up, if error rates spike up, if an IP address bombards your infrastructure. But without these, you are effectively driving or flying an airplane with your eyes covered. With this, you will know what is happening. So all of them, as I explained in the previous minutes, can take up the multi-layer security approach we believe in. And this is the perspective I want you to take away and to implement, even if you are not yet a Traefik user, but still the general principle applies. But if you are a Traefik user, look these things up in our documentation and try to configure it as soon as possible. And to help you with that, Dan has prepared a demo and he will walk us through to configure these things and show us live. So then I stop the screen share and the stage is yours.
Sounds good. Thanks, Emmanuel. We will kick off the demo here. So we're going to kind of walk through this in the same order that Emmanuel presented in the slides. So we'll kind of start with kind of how not to deploy an API. So we'll start with an open and unsecured API and kind of show that, and then we'll jump into more of the secure methods. So the first one here, this is just going to walk us through the different pieces of the configuration. So we've got our config map, we've got the script prefix, basically just the deployment that's needed for a bare bones API to be deployed. So we're gonna we'll look through that. Here's the ingress route that basically gives us our path and how to expose that endpoint. And then we can just curl that. Here we can see that we're just using HTTP. We're not passing any keys, any JOT tokens, any sort of authentication at all. This is just a wide open API. So this allows us to do that. And then, also kind of on this same thread, there's no rate limiting, there's no quotas. So I can call this as many times as I want, and I will constantly get that return back. So that gives us, just maybe a not too good way of how to do that. So let's jump in now to, what it looks like when we secure this. So if I switch over to this secure method here, so we'll kind of walk through this in the same order. So we'll start with like the TLS config, and we'll kind of go from there. So we'll kick this off. This is showing the TLS config. So those of you that are familiar with Traefik know that there's a static and a dynamic configuration. So this is the static configuration. And then we jump right into basically the dynamic configuration on the ingress route of using web secure, telling us, to use this TLS cert resolver for Let's Encrypt. And so just by making those couple of changes and being able to set that up and tying this into the subscription where we can kind of create the API keys, that sort of thing, right? So that's all done. You can get to the gateway through the Hub UI. And you can also programmatically create all of your API keys as well. So we'll jump into the portal here. We'll grab or show you how to grab the API key. So we go in, we see the plans that are available. I can go into my actual application that's exposed. Here's where I can create a key. So I have one already created. We can create a secondary key if we need to. Copy that, and then once we have that key, we're able to go back into the developer portal where we can see the endpoints, all that good stuff. We can actually put in the key here, paste and call that. We can also just grab the API URL from the examples, come back to our terminal window, and we can call that. Now, we'll see here that a couple of things have changed from the previous version of this. So now we're using HTTPS. So we're calling this, using Let's Encrypt. And we're also passing it the API key. So we've kind of, accomplished a few things here. You can also see the rate limiting has been applied already. So we'll kind of touch on that in a second. But this output shows us, calling the same API with the same response of, the mock forecast, I guess, for these few cities. But we're doing that all, using Let's Encrypt and over a secure uh, API endpoint using the API key method. So if we can continue on here, we'll start looking at the next piece here. So we can talk about, and we'll look at the API plan. So we can see that, of course, from inside the UI. So we can see the rate limits. Now these rate limits are set probably artificially low just to make it easier to demo, so we can exceed that rate limit really quick. But this also shows us, from a GitOps perspective, how we can declaratively manage this as well. So we can set those rate limits and quotas from here. And so right away we see if I do two requests, within, a couple of seconds, I get a 429 response code basically saying too many requests. So that just shows us, that the rate limiting works and a way to control, how many people and what type of access, whether this is related to billing and, some type of a contract that allows your consumers to use a set amount of calls per month or however that contract is written. This is a way to do that, and then you can see what that usage is on that. So from here, we'll jump into the WAF. So we'll just clear the screen here, and then we can look at the WAF configuration. So just like Emmanuel showed in the slides, got the WAF firewall configured as a middleware. And that is set up to basically block everything. So if I make a curl request and just put a simple, like cross-site scripting, this could have been a SQL injection, any of those type of requests, we'll get that 403. So we're getting the forbidden response from that because the firewall is seeing that, it's blocking that request, and we'll be able to block that. So jumping right into the AI service. So this is a good way to kind of help manage your AI endpoints. So this is going to allow us to create an AI service. So this specific example is using Gemini. So I've got Gemini configured here, give it the model and my API key on the back end. And then from my end user perspective, all I have to do, or all I need to do, is set up that same ingress or ingress route, give it a name, namespace, set up the rule for that. And then we can curl and send the same request to Gemini through Traefik. So this allows us to manage and look at, we can do rate limiting, we can secure this, we can do all the stuff that we do with a normal API, but this is just calling a LLM on the back end, so your end users don't have to have direct access to the AI endpoints. You can expose all that and manage that all through Traefik. This simple example basically just shows us, asking Gemini to tell us a joke, and so it outputs that nicely here for us, so we can use that to call those LLMs and manage that as more and more customers are looking at the LLM side of things. And then finally, the last little demo that we have here is all around the doing the open API spec and not allowing shadow APIs to be accessed. So we will share this one here and we will walk through that. So we'll start this one. This will take us through. So we look at the gateway. We can see our Treble plugin is configured. So this is actually kind of a cool feature with Traefik and Treble integration, where we can see all the different requests that we've made. We can see the response codes. We can filter this, so we can really get in and look at our traffic that is coming in and see different things from here. But from this point, I can, I've made several calls. It looks like I made about 75 requests so far. If I look over into Treble, I can see the same request here. So everything's being sent. And then I can just jump right into the API documentation that Treble is collecting. And we see here that they give us a URL, and then we can also open this in a Swagger editor. So we can take a peek at this and see, what is Treble generating based off of our traffic that we've sent. So they're generating the API spec for us. Now, when I was setting this up, we intentionally made just GET requests. So that's really all that Traefik has seen. So, in a real world situation, you might want to do all the different methods and stuff that you want this to document if you're using this to build your API or your Open API spec. But this, for demo purposes and for showing this, I kind of wanted to keep this to just a GET, so we can kind of show what it looks like when we try to call a method that's not part of our API spec. So we will grab this, and I've gone ahead and I've applied that, but I pulled up a kind of a diff here between what is generated from Treble and what we have as our full Open API spec, and then we apply that. So this just shows that we're applying the Treble um, Open API spec. Then on the API, we have put in the validate request method and path. So that basically is saying, any request that comes in, we're going to validate that against the Open API spec. So based on how I created that, I can run the git command. So I see that that returns, I'm getting my output. But if I try to do a delete or a post or any type of other command, I will get a 404 basically saying that it's not found. And that's by default because that's how we built this feature to work, that it's not found in that Open API spec. So if I would put the full API spec back in or add these sections to the newly created Open API spec, this would begin to function. So it gives you a way to eliminate those shadow requests. And this validate request method and path can be set at individual API level, or you can turn it on for like the entire instance. So you can put this into your static configuration, turn it on, and then you can turn these off individually at the API level if you need to as well. So there's two different ways to configure that setting, either globally or at the per API level. And with that, that wraps up the demo portion. So